So the next topic that I wanted to discuss is about the different capabilities and to show you what are the state of the art development that people are doing and how we are trying to make it reachable to everybody, and then also build on discussion onto it, so that it can be a continuous development and it can be a community driven development. So with this vision, actually, a team of colleagues who are very much active in the community, they they thought of actually establishing this new journal, which is OpenFOAM journal, and it is a flagship journal of the OpenFOAM community, and it's one of a kind. I will just try to explain why it's one of a kind soon, but this is the unique platform where you can publish your development with OpenFOAM, and also it creates a huge resource for us to learn further, and also for beginners who want to start using OpenFOAM for their research or teaching on any particular field. So you can easily go and check this out, the whole website. I hope that the journal website is visible to all of you. And you can basically, starting from, if you go the about of the journal, you can actually clearly see what is the vision, in which vision this journal has been started. So it basically clearly says that it publishes original papers to the OpenFOAM computational library, which are done using OpenFOAM. And we have a set of different categories that we publish. However, I would like to highlight that this discussion we had a lot within our editorial team, that the papers are not expected to make a huge novel scientific contribution here, but rather we publish the contributions which made a novel contribution in the development of the OpenFOAM code for the use of any scientific problem. Okay, so that is something I want to make it first clear. And then if you basically go to the editorial team, you would be able to see that we have a number of colleagues, and I'm quite fortunate to be included in this. And you can see we have a large editorial advisory board who are again very much active and well known to contribute in this community. And particularly the course that you use are basically developed by many of these people. And for example, you will be today we'll be listening to Dr. Philip Cardiff, who is also part of this editorial board. But yes, so first things first, if you are a beginner, you can go back and come see the team that is supporting this journal platform to see who are the active people, you know, in this community, and what they actually, in what aspect they are developing OpenFOAM. And um, yeah, I mean, they are wonderful colleagues, and they are very happy to help and support the mission of this open source platform for CFD education. And I strongly, if you find someone working in your field closely, I strongly suggest you get in touch. If you are stuck somewhere, and build it up with them, collaborate with them. Yes, so basically, you are very much welcome to contact us, get in touch, tell us what you are developing, and will you be willing to publish it in this journal to make it available for everybody so that others can build up. And then now the next thing is, I will basically go to the journal issues, and you can see that we have started publishing from 2021, and now there is at least 5 issues or 5 volumes. This year it's 5th volume. And I would try to highlight some of these papers. Those are particularly I followed and helped me a lot because in my area, but there are papers from different areas here. But if you go to any of these volumes, what you can see is that in each volume there are papers. such as, first volume, it is published by Professor Harv Jesak on analysis of nasal flows. Then we have on novel development on inverse heat conduction problem. We have Hakan is very valuable contributor in OpenFOAM community. I might also share the link of his MS PhD course in OpenFOAM, which is again one of a kind, and it has a lot of resource from very long time, uh, from the start of this OpenFOAM, and I learned a lot from them. So they have published papers on turbine transients. Then if we go to volume 2, you will basically see publications, and as you see that as we are going ahead with the year, we are getting more and more submission in a very different area. So for example, artificial compressibility, coupled actuator, then numerical modeling of residual seabed liquefaction, very applicable to many industrial problems. Then apart from that, which might be very useful for beginner level understanding the basics of OpenFOAM, is some review articles which are quite popular. So we have a review on modeling of wave structure interaction. It's a very popular article. And then there are basically papers on post processing, visualizing CFD results, then manufactured solution to access the convergence order in OpenFOAM. It is on numerical schemes. Then we have head loss pressure boundary condition for hydraulic system. We have overset meshing for a comparison between overset mesh and morphing mesh for vortex induced vibrations. Then there is a paper on integrating a new membrane fluid structure interaction solver. We have a modified method for lead driven cavity. There are many different development of using Python for automating, for post processing, for different kind of activities that can be done within the OpenFOAM framework, and so on and so forth. So I will just go in each volume and just kind of try to highlight the areas that people are contributing and publishing, and these are the state of the art development using this software, right? So for example, again, a convective heat transfer problem. We have turbulence modeling problem using different type of turbulence modeling, such as here Spalot-Alamus model. Then there are boundary coupled multiphysics problem. Another very popular article, how you can couple OpenFOAM with other open source tools using Precise, as I told before. So it has been very popular, and a lot of people are using it for their research. There are papers on polymer electrolyte fuel cells, hybrid LES range simulations. Then for multiphase flows, the isovector volume of fluid method. So this is very useful for interface capture in the multiphase flows and has become very popular. Then there is again over uses of overset mesh for flexible bodies such as fish swimming. There is sensitivity analysis framework for unsteady flows, given with an example of pitching airfoil. There are solvers for two-phase flows, and there are again cyclic heat transfer solver for OpenFOAM. Um, then if we go to 2024, we have got papers on RANS modeling, and improvement of RANS modeling, and elliptic blending model for that. Then capability in a two-phase Eulerian flow for sediment transport application. Then there is simulation of high-speed reactive flow, and then CFD-DEM coupling, and simulation of metal powder conveying for laser metal deposition. Again, modification of overset motion for flexible flapping foils, modification of volume of fluid solver with phase change, and um, post-processing papers such as how to compute Lagrangian coherent structure, and so on and so forth. And currently we are in 2025, where you can see we already have a lot of projects such as how to test your development. how do you incorporate very robust testing strategies for your projects. We have thermoelectrodynamic convection in rotating spherical cell. We have a framework for modeling the evolution of fiber orientation, coupling strategies for conjugate heat transfer problem, um, development of a new solver to investigate the dynamic absorption and desorption processes in metal hydrides, then solver for viscous fluids to simulate lava flows, and then again modeling of a turbulence model using gamma transition model for capturing turbulence flows. So again, very briefly, my motive for showing you all this was to get overall view of the state of the art on what kind of work people are doing in the community and how OpenFOAM is being used for different aspects of fluid dynamics, solid mechanics, and as well as different multiphysics problem. So I hope it is useful to you to kind of get a word map, keyword map for all the different areas that is being used, but they are not exhaustive. So OpenFOAM code is vast. So I would basically suggest um, looking into the rich set of tutorials OpenFOAM already has, and I hope you will find the relevance to your own research and teaching. Okay, so with that, the last thing I want to talk about the specific unique point about OpenFOAM journal is that if you can see any, so for example, this paper has been published in just the last month, which is modifying a new transition model um, for RAN simulation. And you can see that if you go to this website, the interesting part, I hope you can see my cursor. Interesting part is that if you click this paper, you will see that uh, there is not only the paper PDF, but we have the associated source code and the case files. So as part of this journal community, we give a lot of importance on reproducibility, and that's one of the major criteria for getting these papers published in OpenFOAM journal is that whatever development we do has to be shared with an appropriate reproducibility note, which means that we have to be having the source code quite transparently available to the users, which they can then compile and modify if needed, and also the associated case files to test different kind of demonstration that has been given in the paper. Okay, so this is a very unique point. It's not the only one. Nowadays any open access journal article basically kind of makes it mandatory to share all the associated codes and results and everything, but particularly for OpenFOAM community, I think this is a major development, because if you are interested in one of this paper and then you have to develop or you need to add some more complexity or capability to this code to solve another challenge, you can start on the shoulders of the giant without reinventing the wheel. You don't have to really do this work again. You can cite this paper, reference this paper, and take their source code and develop your own capability, and with, of course, with the due credit with the authors, and then you can solve more challenging problem. And that's how we aim to advance in science or advance OpenFOAM for more challenging problems. The last thing here is that that's not all. We also have a discussion forum associated with each paper. And I think this makes it a bit of very unique, because till now we just used online discussion forums, and I have to say CFD online is uh, lifesaver, because when as we learn CFD, we develop our codes, we get stuck, we don't know how to go ahead, we ask our fellow computational researchers about our doubts, and they are very kindly take their time to give you hints and try to solve your problem. And we wanted to actually embed that culture into this journal. And and there is, as you see, for each paper we have a discussion forum. And if we go to the discussion forum and click the discussion forum, you can see with the authors and the year and the title, we have a discussion link already in CFD Online. And what it does is it basically gives you the opportunity to ask questions to the authors if you are wanting to develop this further, or if you basically have some doubts that you want to clarify from the authors, or in any case if you are not able to compile their source code with the new versions, etc., etc. But I think this is a very progressive step that OpenFOAM journal has been taken, that not only to publish the paper but also advance and building up based on this. And I just go to an older one just to show you some example. For example, if we go to 23, let's say randomly, and if we go, let's say this one randomly, and if we go to discussion forum, you can see the discussions between the users and the authors, right? So that's, I think, and even the editors are available here to moderate the discussion. So this is an amazing way to build on existing state of the art publication that are getting published in OpenFOAM journal. All right, so I think with that, again, I think this is what I wanted to communicate in terms of showing you the OpenFOAM journal and the newly published state of the art papers, and what are the unique points this OpenFOAM journal gives you. And along with that, I think I will show you the websites that I promised, and I basically showed in my presentation. So the first one is openfoam.com. So if you basically go and search openfoam.com, you will see that this is a very well maintained website. And now, as you can see, that the newly it has been acquired by Keysight. So Keysight is the maintainer of openfoam.com version. And this website has a lot of information, so I suggest you to go to each of the tab and see which one you can see. For example, the most useful for you here for this workshop is the training part, not the training part, sorry, documentation part. The training part, of course, there are trainings, official trainings provided by the maintainer, which has its own fees. So if you are interested, or if you are a PhD student who want to, who have some budget to go for training courses, you are very much welcome to, register for the courses. They have different kind of trainings, virtual, on site, etc., etc. However, for everybody who can access the more information for free, as the notion of open source software or open source tool is the documentation part. And in this documentation, I want to highlight the one which is basically, there is a tab called tutorial wiki. And if you click that, you go to a wiki page, which is very, very useful. So for example, if you go to the content, you see getting started. And if you go to getting started, you see the OpenFOAM code wiki, build instructions. So for example, if you go to OpenFOAM code wiki, from here you go to basically the GitLab repository of the OpenFOAM code and its build documentation. Then you go to build instruction, which is basically gives you the instruction to compile this open source code from source, and then the OpenFOAM repository, right? And the third party repository, which you basically need to compile the code. Then if you go to OpenFOAM governance, which is a structure which basically has all the technical committees, which is useful to know what are the different technical committees and special interest group exist. For example, there is a technical committee for documentation and tutorials, which I am fortunate to be part of. And then we have a high performance computing technical committee, meshing technical committee, multi-phase, numerics, optimization, and turbulence. And if you click this, you will basically getting to know who are the people are quite active, and they regulate or steer the discussions, new developments in this particular area, for example, turbulence. And then apart from that, there are also a number of special interest groups, and you can basically go to special interest groups like marine, nuclear, turbomachinery, data driven modeling, research software engineer, etc. And you can, for example, if you go to data driven modeling, you will see the different events, hackathons, and so on and so forth organized within the special interest group, which gives an excellent platform for learning it more. But apart from that, the most important part at this stage is the tutorials. So if you go to the collection of tutorials, this gives you a huge, group of resource, and you can see it's very well structured. So if you can go to the first glimpse series, 3-week series, collection by contributor, and where you can click all the contributors' names to see what are the tutorials are available, and if that is relevant to you, and so on and so forth. And this is very, very useful. Then there is a collection by topic, for example, pre-processing, basic CFD, post-processing, programming theory, etc., etc. So it's quite useful. And there are the new exafoam benchmarks are also available for GPU computing, and so on and so forth. So this is quite useful. Then you have the code wiki, tutorial wiki, and you have the in the download, you can download the recent versions for Windows, Linux, Mac OS, etc. And some of the instruction that I've already provided for compiling the code in different OS comes from here. The other folder is the openfoam.org, as you have seen, and you can see the recent version here is OpenFOAM 13, and it's maintained by the OpenFOAM Foundation. And similarly, they have downloads, the recent versions, developments, resources. There are also a good resource here, and there are other things which is you can explore in the website. So, all right. So